Welcome to Physics Advanced Level Paper 2. We are going to continue today with June 2001 question 3. In our previous lesson, in our previous revision episode, we answered question 2. So you might want to go back and check that. Before we continue, please, I will lead on you to subscribe to our channel. That is the only way you can support us for now. Like our video, subscribe it, share with your friends. Thank you. We are going to look at the question, and it reads: a car is normally threaded with wire loops. Donlop tires have about 200 loops a tire. A car running on such tires travels at a speed of 16.7 meters per second along a level road such that the magnetic field of the head makes an angle of 53 degrees with the axis of the tire at all the times. If the magnetic field is 1.2 times 10 to the power minus 5 Tesla, calculate. Roman 1. The induced current through a loop. If the tire's diameter is 0.65 meters and the resistance per unit length is 8.0 times 10 to the power negative 3 ohms per meter. This question actually it has to do with magnetism. It is true, you might have heard that the question is beyond advanced level, and most maybe pamphlets you've seen, the question was not answered inside. We are going to attempt to answer it by reasoning what happened there. What I want you to focus on is the tire has wires inside. The wire is a coil. It's a coil that is carrying current. So as the tire moves on the road, it is actually moving in the Earth's magnetic field. So when we have a conductor moving in the Earth's magnetic field, what happens is that there is going to be an induced current that we can calculate using the Faraday's law. So the first thing we will do is we're going to collect the data that we have there. So the number of loops, you have 200 loops. The speed has been given as 16.7 meters per second. The angle with which the tire is inclined to the magnetic field, the Earth's magnetic field, is given. The magnetic field itself is given, B. The diameter of the tire has been given, and the resistance per unit length, small r, has been given. So small r is the resistance divided by the length. And the value has been given as this. Now, I've done a little bit of some manipulation here to have length all over r, which gives me 1 all over the resistance per unit length. Why am I doing this? Because I'm going to use it in the formula down here. So this is a solution, a proposed solution. The induced current I is equal to the magnetic field times the number of loops times the length, the speed, sine theta, divided by r, where r is the resistance. So if I have to bring in the idea of the resistance per unit length, the small r that we have here, we have L divided by r. This L on r becomes 1 all over r. So if I replace L on r, I'm going to have this formula here, Bn V sine theta all over small r. And our induced current I becomes this. We substitute the values, will give us 3.4 ampere. This is a current that is induced in the 200 loops of wires. But our question says we should calculate the induced current in a loop, which in this case is 1 loop. And so we will take this divided by 200, and we'll have 1.7 times 10 to the negative 2 ampere. Normally, I could have done this here by putting 1 in the place of 200. But I choose to put 200 because I will use this answer in the subsequent question. So we'll go to Roman 2. Roman 2 says, how much power is generated on the tire due to the motion in the Earth's magnetic field? We have been given the diameter of the tire to be 0.65 meter, and we can get the radius. We'll actually work with the diameter. We could get the radius also by taking diameter on 2. And we've seen this, that the resistance per unit length is a resistance divided by length. So if we make the resistance a subject, we'll have resistance per unit length times the length. The length of this wire here is the same as the circumference. So we have 2 pi radius. 2 pi radius. So that gives us the length. So if you put it here, we have the radius times we have the resistance per unit length, times 2 pi radius. So if we come back to our solution, the power generated is I squared, the current square times the resistance. So if I replace the resistance with RL from up here, I will have this. And I replace L with 2 pi radius. as a circumference. I'll have this, and next thing will just be to substitute the values of current, and you can see that the current here, since they are asking for the power generated in the tire, the entire tire, which has 200 loops, I use 3.4 there as a current instead of the 1.7 that times 10 to the negative 2 that we had. So if you do that, you have a power of 0.19 watts. 0.19 watts. And we'll continue to the next step, which says, Romans 3, what does it suggest to you about the usage of threaded tires? I've included a picture here to show what I mean by threaded tires. So you have this thread, and inside there you have wires. So we have this, that the threaded tires, or threading a car tire, will increase the strength of the rubber casing. When we add those wires inside, increases the strength of the rubber casing. As we have seen, the power that is generated increases the strength. Threaded car tires also increase its rigidity, so that it cannot easily change its form, cannot easily get deformed on the road or press as the rubber moves on the road. So it helps it to become rigid. The threads also help the tire to grip the road very well, so it helps to increase the friction on the road, and so on. So that is it for question 3 of June 2001 A-level physics, paper 2. So thank you for watching this video. Would like to know how you feel about this video, so please leave us a comment, and don't forget to subscribe to our channel, like the video, and turn on your notification so that you receive notification each time we post a new video. Thank you so much, and our next video will be on question 4 June 2001 paper 2, our next video, hopefully tomorrow. Thank you so much, and bye.